Filtering Pandas data frame is not only easy but interesting as well. It gives us the easiest ways to filter data in data frame and pull the exact data that we want. It is just like writing simple SQL queries and getting the data from the database that we need. In the previous few videos, we have been working with Pandas data frame and we have learned a lot about them. In today's video, we are going to go further and filter our data inside Pandas data frame. Let's go. So I've already imported pandas as PD in this Jupyter notebook that you can see on my screen, and then I have imported the employees.csv dataset and assigned that to df variable. First of all, let's check a few rows of this data frame to see the column names and see a sample of data. Let me press shift enter and we can see that it is returning the top 5 rows of the data frame, and we can see that we have employee ID, full name, job title, department, business unit, gender, ethnicity, age, hire date, annual salary, bonus percent, country, and if we scroll to the right we can see that there is another column city and we have exit date. So these are the columns of this data set. Let me check the column names in a list as well. So for checking the column names, I can say df.columns. If I press shift enter, we can see all the column names in a list that exist in this data frame. So if you see that there is a column by the name of country in this data frame, and let's see all the values that this country column holds in this data frame. For checking that, we can say that df.country value counts. Value counts is a function that will tell us how many times a value has been repeated in this column. So if I press shift enter, it says that in this country column we have only 3 unique values. United States has been repeated 643 times, China is repeated 218 times, and Brazil is repeated 139 times. So if I want to filter this data frame and see only those rows where the country is Brazil, first of all I need to create a condition or a mask for that. For example, I can say that df inside brackets or df dot, whatever notation you like. I like this way. For example, df dot country is equal to Brazil. If I press shift enter, it will give us a boolean result where it will show false for all those rows where the country is not Brazil, and it will show true for all those ones where the country is Brazil. Currently, because we are only seeing the top 5 rows and the bottom 5 rows in this result set, therefore all the values are false that we can see. In the middle of them, where the result is truncated a bit and we only see 3 dots here, there are some rows where the country is Brazil, so we cannot see them here because they are hidden. That's why we do not see them here, and all the values look like they are false. So currently df.country is equal to Brazil is a condition that we created, or we can say it's a mask. Let me call it a mask or condition. So mask, and let's assign this to this mask variable. Now we have assigned this condition to a variable, and now we can use that variable inside our data frame filtering process to filter this entire data frame and see only that data where the country is Brazil. So for that one, we can say df, and inside this square brackets we can assign this condition or this variable because both of them are the same. So first of all, let's use the variable name, and if I press shift enter, it will return this data frame, but it will return only those rows where the country is Brazil, and we can see that all the values in this country column is actually Brazil. So we are filtering our data frame based on a specific condition, and the data frame will return only those rows which meet the criteria that is defined in that condition or that mask variable. We can do it this way, or we can directly pass that condition here. For example, we can write df, and inside square brackets we can say country is equal to Brazil. If I press shift enter, it will return the same data frame again. Now that we have filtered this result based on this specific condition, we can chain this with another square brackets, but before that let's clear this, and for the purpose of simplicity let's assign this mask variable to this, and press shift enter again. Now because we have filtered this based on rows, let's now filter this based on columns as well. For example, if I don't want to see all the columns for this result set and I want to see only 3 or 4 columns, I can add another square of brackets, and inside a list I can provide the list of all the columns that I want to see, and we have learned this in the previous videos as well. So let me add another square of brackets for adding columns, and inside this square of brackets let's provide a list of column names. For example, I want to see department, comma, gender, then country, of course, because I want to see if it's returning all the values or all the rows of Brazil or not. And then at the end, for example, I want to see age column. So what I'm doing here is that I'm just passing this condition to this data frame to filter this data frame by rows, and after that I'm adding another square of brackets, and inside that square of brackets I'm providing a list of columns to see only these specific columns in the result set. If I press shift enter, we can see that the returning data frame has been reduced to 4 columns only, and here only those rows are returned where the country column contains value Brazil. And at the end we see a summary that it is returning 139 rows, and we saw before in a previous query that Brazil was repeated for 139 times in this data frame. And remember that this df mask and the column names, this is returning a new data frame, and we can use all the functions on this data frame that we have been using on a specific data frame in the previous videos. It means that this is also a data frame, and all the functions and attributes that other data frames have, this is also having the same thing. So for example, let me add a dot and head, and it will return only top 5 rows because this is a data frame as well. If I press shift enter, this is returning the top 5 rows of this returning or this result set data frame. Now that we have seen how to filter a data frame based on rows, we can filter a data frame based on conditions on columns as well. For example, we can say that show me all the columns where the data type is object, or where the data type is integer, or it's a date time. So we can add conditions based on columns as well. Let's see it in action. For example, we have an attribute on data frames that is dtypes, which will return the data type for all the columns. If I press shift enter, here we can see a result. In this result we can see that there is a data type defined for each column. Employee ID, full name, job title, everyone has object data type, but age is int64, and everything else is actually object data type. Of course, we can change some data types here. For example, we can change annual salary or bonus percent, or for example hire date to date, but we will not do that because at least we have one int64 data type in the age column. So it is returning data types of all the columns, and now I want to see all the columns of a specific data type. So let's do that. Let's first create a condition again. For example, df.dtypes show me only those columns where the data type is int64, and if I press shift enter, it will return a boolean result where we will have false for every column where the data type is not int64, and it will return a true for that column where the data type is int64. So this is easy. Now we want to assign this to a variable again. For example, mask. This is for the simplicity purpose. We can assign directly the condition as well. If I press shift enter, now we have assigned this condition to mask variable. Let's store this condition there and we will use it later on. Currently we have another attribute, and that is df.columns. We have seen this previously as well, where it returns the column names of a data frame. If I filter this data frame and I assign all the column names to this data frame, it will return the entire data frame with all the columns that you can see here. But currently I do not want to see all the columns. I'm adding a slice here, and I want to see the first 3 columns. So I can add a column, specify the first 3. It will return column 0, 1, 2. We know this from the previous videos. If I press shift enter, we can see it's returning the first 3 columns: employee ID, full name, and job title. And we can do this here because we have added a condition that is a slice, and it's returning the result based on that condition. Now instead of this slice, I can provide another condition that we have already stored in this mask variable. I can say mask. This mask says that show me all the columns where the data type of the column is int64, and we know that there is only one column, age. If I press shift enter, it will return only that age column where the data type is int64. So this is how we can filter columns as well, based on data types, based on a name, based on a slice, or anything else. If I want to negate this condition, for example, if I want to fetch all the columns where the data type is not int64, I can just add a tilde sign, and it will tell this query that give me all the columns where the data type is not int64. If I press shift enter, we can see that all the columns are returned, but we do not see the age column here, because the age column is of type int64, and inside this query we have mentioned this, that give us all the columns which do not fulfill the given criteria. So the given criteria is to check for int64, and with this tilde sign we are saying that give us all the columns that are not int64. So we can do this as well. And again, the returning data frame is a data frame, and we can just apply all the functions on this like this. Just like we saw the previous conditions, we can chain multiple conditions as well. For example, if I want to see all the data for female or for male people in this data frame, that will be one condition. Chain another condition. For example, I can say give us all the data for IT department people. So first of all, I filter it for female, then I add another condition, that is give us all the data of female with department IT, and I can add more conditions. For example, I can say in the third condition that give us all the data of female people with department IT, and the country should be China, like that. So we can chain these conditions as well without using any logical operators first. Later on we will see how to use logical operators, but first we can use multiple conditions, or we can chain conditions with each other to filter data based on different conditions. Let's see this. First of all, let's check the conditions. For example, I want to see data for male colleagues first. So I can say df dot gender should be equal to male, oops, not make, male. If I press shift enter, it is returning true and false. False for female colleagues and true for male colleagues, because male is what we want here to see. So we are adding this condition, and let's add this to a variable, and that will be m1. Now in the second condition, for example, I want to see all the data for a specific department. For example, I want to see df dot department should be equal to accounting, for example. This will be the second condition. And in the third condition, I want to filter this data frame based on country column, and I want to see all the people from Brazil, for example, not China. So these are the three conditions that we are defining here. Let me press shift enter to run this. Now we have these three masks, m1, m2 and m3. And now first of all, let's assign one of them to data frame. For example, based on mask 1, let's filter this data frame. If I press shift enter, we will see that this is returning this result, and we only see male people here. We do not see any female, because we have assigned to m1, that is mask 1, and in mask 1 we have assigned a condition, that is we want to see only those people who are male. So this is one condition. Now for adding another condition, the second one, I can just chain another one, and I can just open another pair of square brackets, and inside that I can add m2. Now we can see that we have people from different departments from male gender, but if I press shift enter this time, now we will only see people from accounting department, because in the second condition we have specified that department should be accounting. If I press shift enter this time, now again we see people whose gender is male and department is accounting. So now it fulfills both of the conditions this time. And for the third condition, we will open another pair of square brackets, and inside that we will assign m3, which will be mask 3. If I press shift enter, It will then filter this result again, and from this data frame it will get all the rows where the country is Brazil, not United States, not China, but only Brazil. If I press shift enter, now it has returned the result based on these three conditions, and we have only 3 rows in this entire data frame where the gender is male, the department is accounting, and the country is Brazil. So we have filtered this data frame 3 times. First of all, we filtered it based on gender column where we returned only those rows where the gender was male. Then in the result we had another new data frame, and we filtered again the new data frame based on another condition, and we filtered it for department column. This time we selected only those rows where the department was accounting. So it gave us a brand new data frame again for the second time. And now again we assigned it a third condition, and that was we want to see only those rows where the country was Brazil, not United States, not China, but only Brazil. And it returned another new data frame, and we have that here. We have 3 rows where it fulfills all the 3 conditions that were defined before. So this way you can chain multiple conditions to filter data frame records. Now that we have seen how to chain multiple conditions, we have another way for chaining multiple conditions, and that is the use of logical operators. We can use logical AND operator to chain multiple conditions with each other, where the result will be true only if all the conditions are true at the same time. If only one of the conditions is false, the returned result will be false. For example, let me paste the previous conditions again here. And first of all, let's filter the data frame based on mask 1. If I press shift enter, we can see it will return only those rows where the gender is male. Now this time I do not want to chain conditions. I just want to add logical operator, and that will be logical AND operator like this. And I will say that filter this data frame based on mask 1 and mask 2, and let me add mask 2 here. If I press shift enter again, now it is returning this data for both conditions, gender male and department accounting. And similarly, we can just keep adding the AND operator, and we can just keep adding the conditions M3. If I press shift enter again, we can see that it is again returning 3 records where gender is male, department is accounting, and country is Brazil. Remember that we are using variables here, that's why it is very simple to use. If we do not want to use variables and instead we want to add conditions directly to this data frame filter process, we can do that as well. For example, first of all, let me add the first one, that is gender is equal to male. If I press shift enter, it is giving us this result where gender is male. Now if I want to add AND again, we cannot just add AND right here. First of all, we need to enclose this condition inside a pair of parentheses like this, add AND operator, open another pair of parentheses, and inside this pair of parentheses we will define another condition, and that will be the second one, def department must be equal to accounting, like this. So now we have 2 conditions. If I press shift enter, now it is fulfilling both of the conditions, and it is returning rows where gender is male and department is accounting. And we can keep adding these conditions like so. Open another parenthesis and define another condition, that will be country is equal to China this time. If I press shift enter, we are having multiple rows where gender is male, department is accounting, and country is China. And we can add other conditions as well. For example, let's keep on adding and define another one. Let me open a pair of parentheses, def, where for example age is less than 40, like this. If I press shift enter, now we see only 4 rows where gender is male, department is accounting, country is China, and age is less than 40. That's it. So we talked about the AND operator. Now let's see OR operator. OR operator does the opposite of AND operator. For example, if we have 2 conditions or multiple conditions, then the result will be true if only one of the conditions is true. So if even one of the conditions and 10 conditions is true and 9 of them are false, the result will be true because one condition is true. For example, let me add two conditions. First, return df where the country is equal to China. So this is one condition. Let me add another one. Return where the job title column is equal to Analyst, like this. So if any of these two conditions is true, the result will be true. For example, I can say df filter m1 and, sorry, not and, but this time or operator, and here the pipe sign is the or operator, or m2. If I press shift enter, we can see that it is returning a lot of rows where we can see countries China, United States and other as well. We have rows for China because we defined the condition to select those rows where the country is China. So we have these rows for China, the first condition. We can see that the job title is not Analyst, but because the country is China and only one condition is true here, we see these rows in this resulting data frame. And for this row, we can see that the country is United States, but because the position or the job title is Analyst, it is being returned in the resulting data frame. So if even one of the conditions in the OR operator is true, the result will be true. So if someone is Analyst, it will be returned in the resulting data frame. Or if someone is not Analyst, but their country is China, they will be returned in the resulting data frame. So OR operator returns true even if one of the conditions is true. We can chain both AND and OR operators as well. For example, we can say that give me all the rows where either the gender is male or the country is China, and they must be in the IT department or in the accounting department. So we can chain both of the operators as well. Let's see this in action. For example, in mask 1, I can say that if the gender df gender is equal to male, this is one condition. In mask 2, I can say df age is greater than 50, this is another one. In mask 3, for example, I can say that the department is equal to accounting, for example. So these are the three conditions. Let's press shift enter. I can say that df return mask 1 or mask 2. So it will return all the rows if the gender is male or if they are female but their age is greater than 50. If I press shift enter, and we can see that it is returning all the rows where the gender is male, but for female it will be returned because the age is greater than 50. So we see female only if the age is greater than 50. So in these two conditions, one should be true for the result to be true. Now for the third condition, to filter for this department, we can add the third condition as well, but we cannot just add AND here because it will mix up these conditions. It will not understand which one to prioritize, whether give the priority to the OR operator first or to the AND operator. So for that, we can enclose the two conditions that we want to process first in a pair of parentheses like this. So I want to process the first two conditions first. For example, I will tell this data frame to return the rows whether mask 1 is true or mask 2 is true, and after that check for the third one. So and mask 3. If I press shift enter, let's see here that it is returning all the data for male colleagues and for female only if the age is greater than 50, and we can see it here. So for female less than 50, we will not see them in the resulting data frame. And now after that, when we have this data frame, it is further filtered for the department, and it will only return those rows where they are in the accounting department. So we can chain or we can link both of the operators in one query as well. Now we have another function, that is between function, and we can use the between function on data frames to return the result based on a given range. For example, I want to see all the rows for those people where their age is between, for example, 25 and 30 only. So we can use between function for this. Before between, let's first use our traditional way to filter a data based on a specific range. For example, I can say that filter data frame where data frame age column is greater than or equal to 25, and let me enclose this condition inside a pair of parentheses, and then use the AND operator and give another condition where the df age is less than or equal to 30. So literally I'm saying that give me all the rows where the age column value is between 25 and 30, both of them inclusive. So if I press shift enter, it will return a data frame where we can see that the age column has values between 25 and 30. We can see 26, 7, 25, 29, 26, 29, and we will not see any other age but only this specific range. So this is the traditional way of how to filter data for rows where the age column is between a specific range. We can now use between function for this specific purpose. For example, I can say filter data frame based on data frame dot age column where the age column values are between 25, 30. If I press shift enter, again we have the same result. So in the above result we saw that we had 150 rows, and now in this one we also have 150 rows. So between is literally doing the same thing. It is defining a range where the rows will be returned based on this specific range. And of course it's again returning another data frame where we have 14 columns, and we can filter for columns as well. For that, let me specify a list. For example, a list of columns. I want to see full name, comma, gender only, and age. If I press shift enter, it will filter this resulting data frame based on this new condition where we have only 3 columns listed here. So it will return full name, gender, and age. That's it. So we use between function like this. And now between function has some other parameters. For example, it has this inclusive parameter where we can define a value. We can say that both of these values should be inclusive, or only the left one should be inclusive, or the right one, or none of them. For example, if I press shift tab here and we come down a bit, in the inclusive we can say both of them, neither, none of them, left or right. So if I specify both, by default it's both, it will give us the same result where 25 and 30 both of them are inclusive, and we can see them. We can see 30 there, we can see 25 there. If we say left, it means include the left side value which is 25 and exclude the right side value which is 30. So if I press shift enter, we can see that 30 is now excluded and 25 is already there. If I say right, it means include the right value which is 30 and exclude 25 which is the left value. If I press shift enter, 25 will not be seen there but 30 will be there. And if I say neither, it means do not include any one of them. If I press shift enter, neither 25 nor 30 will be included in the result set. So this is how the between function works. There is another function, isin function, that is used for specifying a list of values, and we can see that give us all the rows where the specific column values are in this specific range or in this specific list. For example, I can say that give me all the rows where the employee ID is ABC or CDE or XYZ, like that. So we can define a list of values in the isin function, and it will return only those rows that we have selected in the isin function. For example, I can say that, let me go to this data frame. For example, I can say that filter data frame where data frame dot full name, let's add square brackets, full name dot isin. So we only want to see those rows in the resulting data frame where the full name of the person is in this specific list. So we can say give us for Nathan Lee, comma, let's add another name, for example this last one, like this. Give us only those rows where the full name column has these two values. If I press shift enter, it will return this data frame for those specific full name values. So this is how we prepare a list of values in the isin function. We can add any column. For example, if I want to see this ethnicity Asian and Latino, I can say that df filter data frame based on this condition where the ethnicity column has these two values is in this specific list. The first one is Asian and the second one is Latino. If I press shift enter, it is returning this data frame where only those rows are selected where the ethnicity is either Asian or Latino. So because the result is truncated, we do not see Latino, but we can see Asian here. Let me add another query. For example, df filter data frame based on this job title column, this time job title, yes, where the job title is in this list. For example, give us senior analyst, comma, analyst. If I press shift enter, we will see this data frame where only those rows are returned where the job title is either senior analyst or analyst. We can see the result here. So we use the isin function to filter the data frame based on a specific list of values. Now that we have seen the isin function and the between function, there is another function that is unique function, and we use unique function to return a list of unique values in a column. For example, I can say df.country.unique. Give me all the unique values in the country column. If I press shift enter, it is returning this list and it says that there are only three values: United States, China and Brazil. If I run this again on another column, for example df.job title, let me use a pair of square brackets, df.jobtitle.unique. If I press shift enter, because it has a lot of unique values, so it is returning the entire list. And if I use it on the gender column, df.gender.unique, we will see that it has only two values, female and male. So this is how the unique function returns only unique values in a specific column. I think it's enough for today. In this video, we learned how to filter a data frame based on specific conditions. We learned how to select specific columns, how to filter data frame based on rows, how to add AND condition, how to add OR conditions, and how to use between, isin and unique functions. This is enough for learning Pandas library. Of course, there are a lot more things in the Pandas library that you can check the Pandas official documentation for. But because if we keep on making videos on Pandas library, it will take a lot of time from us and we will not be able to finish this even in 1 year. So I will finish making more videos on Pandas library, and the next video will be an end-to-end complete data analysis project using Pandas and NumPy, where we will analyze a complete data set and we will extract insights from a given data sets using Pandas and NumPy libraries in Python. So if you are getting value from this video, make sure you give it a like, you leave your comments in the comment section, and you subscribe to the channel. Thanks for watching.